Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, in our last video, we discussed the problems based on the properties of determinant. Now students, in our today's video, we will discuss the concepts related to minors, cofactors and adjoint of the matrices. So we will discuss minors, cofactors and adjoints. Minors, cofactors and adjoint of the matrix. So students, first we'll discuss minors in this. Minors. What is minor? Student, first, if I have a matrix whose general elements are like this: A11, A12, A21, A22. Here A11, A12, A21, A22 are the general elements, general representation of elements of 2 cross 2 matrix. Now here, if I want to find the minors of this matrix A, then I should find the minor of each and every element of this matrix. There are 4 elements here. So for each and every element, I should find the minor. So first, let us see what is the minor of this. Minor of this element. Minor of A11. Here, this 1 represents first row, first column. First number represents row and the second number represents column. So here, to find minor of this A11, we should eliminate the row and the column which is related to this element. Then what I should eliminate? I should eliminate the first row and first column. Then the left out is A22. A22 is the minor of A11. So student, it means to find minor of any element, the only thing we should do is we should eliminate the row and column which is related to the particular element. Then whatever we will get, that is our minor. Then the minor of A12. Here 1, 2 represents first row, second column. So for this, we should eliminate first row and second column. So what is left out here? Left out is A21. Next, minor of A21. Here A21 means it is the second row, first column. Second row, first column. So for this, I should eliminate second row and first column. So the left out element is, or left out number is A12. Next, last element, minor of A22. A22 means second row, second column. This is the element which is located in second row and second column. So you should eliminate second row and second column. So its minor is A11. So student, the minor matrix of this A is minor matrix of matrix A is equals to A22, A21, A12, A11. So student, the minor matrix of this is this one. So to find the minor of any element, the only thing we should do is eliminate the row and column which is related to that. Okay, if this is 2 cross 2, we will get answer like this. What happens if it is 3 cross 3? What we should do for that? For that, what same procedure, we should eliminate the row and column which is related to a particular element. Now the remaining 4 elements we should use RCM, rule of cross multiplication. So let us take a numerical example now. And I will take one example. First one, if A equals 1, 2, 3, 4. Find the minor matrix of A. So here he has given on 2 cross 2 matrix and he is asking us to find the minor matrix of this matrix. So it means we should find the minors of each and every element here. Solution. Since there are 4 elements here, we should find 4 minors. Minor of 1. This is equals to, eliminate first row and first column and get 4 is the minor of 1. Next, minor of 2. Minor of this 2, it is after eliminating first row and second column, we get 3 is the answer. Okay, next. Minor of 3. 3 is located at the second row and first column. So after eliminating first column and second row, its minor will be 2. Next, minor of last element, that is 4, is eliminate second row and second column. So the left out is 1. So its minor is 1. Therefore, the minor matrix of A is equals to, in place of 1 we got 4, in place of 2 we got 3, in place of 3 we got 2, and in place of 4 we got 1. This is the minor matrix of the given matrix. Okay. Now let us take one 3 cross 3 example. How to find the minors if we have 3 cross 3 matrix. Second example. If A equals 1, 0, minus 2, 2, 1, minus 1, 3, minus 2, and it is 4. Find minor matrix of A. He has given this 3 cross 3 matrix and is asking us to find the minor matrix of the given A matrix. This time I have 9 elements. We should find the minors of each and every element. Because student, in a matrix, each and every element has its own minors. Every element will have its own minors. So minors will not repeat, will not get same if the elements are same. For example, here I have 1 and here also I have 1. So this minor is totally different from this minor. So the conclusion is each and every element of matrix has its own minor. Let us see what are the minors of this. Let us start with first row. Minor of 1 is equals to. Now, as I said, we should eliminate the row and column to find the minor of element. If I do like that, then I will get 4 elements here. What are those 4 elements? 1 minus 1 minus 2, 4. So we know in determinant, whenever we will get 4 elements, then we should use RCM there. That is rule of cross multiplication. So what do we get? 1 into 4, 4 minus, we should write after the multiplication of principal diagonal element, we should write minus. Then next diagonal elements. Minus 2 into minus 1 is plus 2. But we have minus here, so it is minus 2. So finally I will get 2 is its minor. Next, minor of 0. Minor of 0. So 0 is present in first row and second column. Now I should neglect the second column, first row. Then what do we get? 2 minus 1, 3, 4 are the 4 elements. Now 2 into 4, it's 8 minus 3 into minus 1, it's minus 3. Already I have one minus from RCM, so this becomes plus 3. So its minor is 11. Next, minor of minus 2. Minor of minus 2 is, we should eliminate first row and the last column. So if I neglect first row and the last column, the remaining elements are 2, 1, 3, minus 2. So if I multiply this, I will get minus 4 minus 3 into 1 is 3. So finally it is minus 7. Next, minor of 2, second row, first column. So this time I should neglect the first, instead of first row I should neglect second row now. Second row, first column I should neglect. Now I have the elements are 0, minus 2, minus 2, 4. So what are the answers I will get? 0 into 4 is 0, minus, minus into minus plus, 2 2s are 4. So answer is minus 4. Next, minor of 1. So here minor of 1 is, we should eliminate second row and second column. So what do we get? 4. So the minor of 1 is 1 into 4, it is 4, minus 3 into minus 2 is minus 6, minus into minus it is plus 6, so it's 10. The next, minor of minus 1, this is equals to, so eliminate the second row and the third column. So if you eliminate the second row and third column, I will get 1 into minus 2, it's minus 2, minus 3 into 0. Okay, students. So the minor of minus 1, this element is minus 2, minus 0, so it's minus 2. The next, minor of last row, first element, 3. This is equals to, so eliminate the last row and the first column. So what do we get? If we completely eliminate this, so this is 0. 0 into minus 1, it's 0, minus 1 into minus 2, it's minus 2, minus into minus, it's plus 2. So finally it is 2. Next, minor of minus 2. Minor of minus 2 is equals to 1 into minus 1, minus 1, then minus in minus, 2 into minus 2, it's minus 4, minus into minus, it's plus 4, finally it is 3, then minor of four, this is equals to 1 into 1, it's 1, minus 0, so it's 1. So student, these are the minors of all the given 9 elements. So these minors are represented in matrix. So minor matrix of A is equals to, first is 2, then 11, minus 7, first row. The next, it's minus 4, 10, and minus 2. Next it is 2, 3, 1. So student, this is the matrix, a minor matrix of the given matrix, and this is the procedure we will use to find the minors of the elements of the matrix. Okay students, after minors, now let us go to the next topic, which is very important in determinants chapter, that is cofactors. This is very, very important. Cofactors. So student, cofactors is exactly similar to minors, but the only difference here is whatever the minors are there, for that we will multiply the hidden sign of the element, then we will get the cofactors of the particular element. Okay, for example, if let me take a numerical example here. If A is a matrix, its element is 1, minus 3, 4, minus 1. Student, if this is a matrix, then so here there are 4 elements. Since it is a 2 cross 2 matrix, we should find the cofactors of each and every element, and after finding the cofactors of the 4 elements, we should write a cofactor matrix. So here, before we go to cofactor, let me write a hidden signs here. Hidden signs, plus, minus, minus, plus are the hidden signs. Student, here we have taken a matrix whose elements are 1, minus 3, 4, minus 1. And since we know that in a determinant, each and every element has a hidden sign. For 2 cross 2 matrix, the hidden sign is plus, minus, minus, plus. Now, as I said, for a cofactor, we should follow the procedure of minus only. The only thing is, To that minor, we should multiply these hidden sign. Then we will get a cofactor of the particular element. Check the cofactors for these four elements. First, one by one. Cofactor of 1. That is the first element. Student. Before I go to the minor of the minor of this element, let me write the hidden sign here. Its hidden sign is plus. Because as I said, if you multiply hidden sign to the minor of the element, we will get the cofactor. So I am multiplying the hidden sign. Now we will take the minors. Eliminate the row and column. In the left out is -1. So the final cofactor for this 1 is plus into minus, it's -1. Next, cofactor of -3, that is equals to its hidden sign is minus bracket. Eliminate the row and the column related to this -3. The left out number is 4 here. So minus into 4, it's -4. The next, cofactor of 4. Cofactor of this 4 is eliminate the row and the column related to this 4. And its hidden sign is minus. Then its minor of 4 is -3. So minus into minus, it's +3. Next is cofactor of -1. Cofactor of -1. Its hidden sign is plus. Its minor is 1. After eliminating the row and column, you get 1 is the minor of this -1. So finally cofactor will be +1. So these are the cofactors of the given 4 elements. So its cofactor matrix will be cofactor matrix of A is equals to -1, -4, 3, 1. Next, now let us check if it is 3 cross 3, how can we find the cofactor? Second example. Write the cofactor matrix of matrix A is equals to 2 minus 3 0, 1 minus 2 4, 3 5 minus 1. So student, here we have a 3 cross 3 matrix this time, and he is asking us to write the cofactor matrix. We know for 3 cross 3 matrix the hidden signs are plus, minus, plus, minus, plus, minus, plus, minus, plus. So first let us try to find the cofactors of each and every elements. For that, what we should do? We should multiply these hidden signs to the minors of these elements. Okay, first, cofactor of 2. So then what I will do, first I will write all these 9 elements, then we'll start finding one by one. Cofactor of -3, cofactor of 0, cofactor of 1, cofactor of -2, cofactor of 4, cofactor of 3, cofactor of 5, and last cofactor of -1. Okay, students, I wrote all the 9 elements. Now let us find the cofactors of this. Before I go to the cofactors, let me tell you the tricks, which is very easy. I will first write the hidden signs: plus, minus, plus, minus, plus, minus, plus, minus, plus. I wrote the hidden signs. Now let us just take the minors of these elements. And we know how to find the minors of 3 cross 3 matrix. Same process by eliminating the row and column of the corresponding elements. So first 2. This 2 is present in first row and first column. So after eliminating that, I get minus into minus plus 2 minus 20. 4 into 5, it's 20. So finally it is minus 18 plus into minus, it's minus 18. Next, minus 3, cofactor of minus 3 is 1 into minus 1, it's minus 1, minus 3 into 4, it is 12. So student here, minus 1 minus 12, it's minus 13. So this is minus of minus 13, it's plus 13 is the answer. The next cofactor of 0, so 1 into 5, it's 5, minus 3 into minus 2, it's minus 6, minus into minus, plus 6. So it is 5 plus 6, 11 into plus, it's plus 11. Next, cofactor of second row first element is 1. Hidden sign is minus. So minus 3 into minus 1 is plus 3. Now 5 into 0, it's minus 0. So minus into 3, it's minus 3. Next, cofactor of minus 2. For this, 2 into minus 1, it's minus 2. Minus 3 into 0, it's 0. So plus into minus 2, this is minus 2. Next, cofactor of 4. So 2 into 5, it's 10. Minus 3 into minus 3, it's minus 9. Minus into minus plus 9. So it is minus 19. Minus of 19. So it is minus 19. Next, cofactor of last row elements, and in that first is 3. So for this, minus 3 into 4, minus 12, minus 2 into 0, it's minus 0, minus into minus, plus. So this is plus into minus 12 is minus 12. Okay. Cofactor of 5. So for this, 2 into 4, it's 8, minus 1 into 0, it is 0. So minus of 8, answer is minus 8. Next, last element, cofactor of minus 1. So for this, 2 into minus 2, it's minus 4, minus 1 into minus 3, minus 3, so minus into minus, plus 3. So this is plus minus 4 plus 3, minus 1, plus into minus, minus 1. So student, I got the cofactors of all the 9 elements. Now let me write the cofactor matrix. Therefore, cofactor matrix of A is equals to, okay, in place of 2 what I got? I got minus 18. So just in place of these elements, I should write its cofactor. And students, cofactors are represented by capital alphabets. Elements are represented by small alphabets. So here it is minus 18, 13, 11, minus 3, minus 2, minus 19, minus 12, minus 8, minus 1. This is the cofactor matrix of given matrix. So student, in general, if I have a matrix like this, A11, A12, A13, A21, A22, A23, A31, A32, A33. So students, these small alphabets, these things represents the elements of a matrix. Where if I have the capital alphabets, that is A11, A12, these capital alphabets represents the cofactors of the particular elements. So its cofactor matrix will be cofactor of matrix A is equals to cofactor matrix. Cofactor matrix of A is equals to capital A 1 1, capital A 1 2, capital A 1 3. Capital alphabets represents cofactors of these particular elements. The next is capital A 2 1, capital A 2 2, capital A 2 3, capital A 3 1, capital A 3 2, and last is capital A 3 3. Students, this is the cofactor matrix of this matrix. So small alphabets represents element of the matrix, capital alphabets represents cofactor of that particular element. Students, this is about cofactors. Now let us go to the next topic, which is again very important. Okay students, this is about cofactor matrix. Now let us move on to the next topic, which is again very important, and that is adjoint of matrix. Adjoint. Student, it is represented by first 3 alphabets of this A, D, J. It is represented by just first 3 alphabets of this. So it is adjoint can be represented as A, D, J of matrix. So students, first, what is the definition of adjoint of matrix? Definition is very simple here. It is transpose of a cofactor matrix. That is the simple definition of adjoint. So student, if A is any square matrix, then its adjoint is transpose of cofactor matrix of A. Transpose of cofactor matrix of A. that is this A. So students, this can be written as adjoint of A matrix is cofactor of A and its transpose. Cofactor of matrix A, then its transpose is called as adjoint of the matrix. So it means we need a concepts of minor here, then we need a concepts of cofactor. After getting cofactor matrix, we should take the transpose. Then we get adjoint of this matrix. Okay, let us see some examples here. First example, if A equals 1, 2, 3, 4, find adjoint A. Find adjoint of A. That is adjoint matrix of adjoint of this matrix. So represented as adjoint A. Students, this is a 2 cross 2 matrix. To find the adjoint of 2 cross 2 matrix, we have a very short method, very easy method. And for that, it is directly I will take the adjoint matrix, because as I said, we have a shortcut for this 2 cross 2 matrix. The shortcut is we should interchange the principal diagonal elements. What we should do? We should interchange this. We should interchange the elements. Means what? First element becomes last, last becomes first. 4 here and 1 here. The next, the remaining 2 elements, whatever it is there, it remains same, but its sign will change. If there is a positive, we will write negative. If it is a negative, we will write positive. The signs will interchange. Change of sign. Sign will change. So 2, it is 2 only, but this time write -2 because we should change the sign. There is a 3 here, we should write -3. So this is the adjoint of this 2 cross 2 matrix without finding any cofactors, any minors. If you follow the procedure, definitely we will get same thing. So we can check here. Cofactor of 1. Since there is a 2 cross 2 matrix, the hidden signs are plus, minus, minus, plus. So first I will write cofactor of 2. Cofactor of 3. Cofactor of 4. The hidden signs are plus, minus, plus, minus. So student, the cofactor of 1, this one is eliminate row and column. So it is plus, we have, so it is plus 4. Then next, the cofactor of 2, eliminate the row and column. Then the left out is 3 and its hidden sign is minus, so it is -3. Then next, the cofactor of 3, its hidden sign is plus. Eliminate the row and column. The left out is 2, so 2 is the minor with hidden sign +2. It is +2. Sorry, student. Here, for 2 cross 2, the hidden sign is plus, minus, minus, plus. Okay. The next, the cofactor of 4 is eliminate the row and column. The left out part is 1. Hidden sign is plus and it is +1. Here 4 minus 3 minus 2 plus 1 are the cofactors of this given matrix. So I will write the cofactor matrix here. cofactor matrix of A is equals to 4 minus 3 minus 2 1. So this is the cofactor matrix. Now what is the definition of adjoint? It is the transpose of cofactor matrix. Now if I want to find adjoint of this, I should take the transpose of this matrix. So let me take adjoint now. So it's adjoint. And we know what is transpose. In transpose, what exactly we'll do? We'll interchange the rows to columns and columns to rows. So first row becomes first column, 4 minus 3. Second row becomes second column, minus 2, 1. Okay. This is adjoint. I got with shortcut method. This is adjoint. I got with the normal method. Both are same. So student, if we have a 2 cross 2 matrix, then we can write adjoint easily without the help of cofactor. So what we should do for that? I will tell you one more time. We should interchange the principal diagonal elements. Interchange. Then we should change the sign of other 2 elements. Finally, we will get adjoint of 2 cross 2 matrix. So student, this is the definition and concepts of adjoint of matrix. Now student, in adjoint of a matrix, there is a very important property, and that property holds good for every square matrix. That is, if A is any square matrix, then the property is A into adjoint of that matrix is equals to adjoint A into A is equals to determinant A into I. That if A is any square matrix, then this property holds good. So what is this property says? A into adjoint A must be equals to adjoint A into A, and that should be equals to the determinant of the matrix A into identity matrix of order A. Now let us take one problem for this to verify this property. Is that any square matrix? Let us take a 2 cross 2 matrix now. If A equals 1, 2, 3, 4, then prove that or verify that A into adjoint A is equals to adjoint A into A is equals to determinant A into I. Question here, I is identity matrix of order 2 cross 2, because here given matrix A is of order 2 cross 2. So I should also be of order 2 cross 2 only. If A is of order 3 cross 3, then I also should be of order 3 cross 3. Okay, given A equals 1, 2, 3, 4. Okay. Student, first let me find the determinant of this. What is the determinant of this? Directly we will use RCM. 1 into 4, it's 4, minus 3 into 2, it's 6. Finally it is minus 2. I got determinant as minus 2. Then let me take the adjoint of A of this. And as I said, if you have a 2 cross 2 matrix, then without the help of cofactor, we can directly write the adjoint with the shortcut method. And the method I will repeat one more time. Interchange the principal diagonal elements. 4, 1. Then change the sign of the other two element. Number remains same, only sign should change. Plus 2 becomes minus 2, plus 3 becomes minus 3. Okay, this is the adjoint A. Okay, now let me try to multiply A into adjoint A. A into adjoint A. What is their matrix? 1, 2, 3, 4. 4 minus 2 minus 3, 1. Student, multiplication of two matrix. In matrix chapter, we studied a concept called multiplication of matrix. And if you don't know how to multiply the two matrix, kindly watch my video of multiplication of matrix. You will get an idea how can we multiply the two matrix. So here, if you multiply the two matrix, we should follow the first row, first column concept. So here students, 1 into 4, 4. Then next, second element to second element. Row to column. First element to first element, second element to second element. 2 into minus 3, it's minus 6. Next, first row to second column. Again, element to element. 1 into minus 2, it's minus 2. Then 2 into 1, it's plus 2. 3 into 4, it's 12. Next, minus into 4 into minus 3, minus 12. Next, 3 into minus 2, it's minus 6. Plus 4 into 1, it's 4. So students, what is A into adjoint A? Minus 2, 0, 0, minus 2. Because here minus 2 plus 2 gets cancelled, and here plus 12 minus 12 gets cancelled. This is A into adjoint A. Next, let us see what is adjoint A into A. So this I will call it as equation 1. This is my equation 1 because I got A into adjoint A. Because this property or identity has 3 parts, and that first part is completed. And I got the answer is minus 2, 0, 0, minus 2. Let us move to the second part, that is adjoint A into A. Into A, that is equals to, first I should write adjoint A, 4 minus 2 minus 3, 1. Then matrix A, 1, 2, 3, 4. This is equals to, again same process, first row to first column, element to element. 4 into 1, 4, minus 2 into 3, minus 6. Next, first row, second column, 4 into 2, 8, minus 2 into 4, 8. Minus 2 into 4 is minus 8. The next, minus 3 into 1, minus 3. 3 into 1 plus 3. Next, minus 3 into 2, minus 6. 1 into 4, it is plus 4. So that here, 8 and minus 8 gets cancelled. Minus 3 and plus 3 gets cancelled. What is left out here? 4 minus 6 is minus 2, 0, 0. Minus 6 plus 2 plus 4 is minus 2. Student, this is my equation 2, my second part. So student, my first part and second part both are equal. Means A into adjoint A is equals with adjoint A into A. Now I should check that these two are equals to determinant A into I. And already I got determinant A value, it is minus 2. Now determinant A into I is equals to minus 2 into 1001. Determinant is multiplied by identity matrix and the value of the determinant is minus 2 as mentioned here. So if I multiply minus 2 to each and every element of this matrix, I will get minus 2, 0, 0, minus 2. This is my equation 3. So if I compare equation 1, 2 and 3, so all three are equal, isn't it? Therefore, from equation 1, 2 and 3, A into adjoint A equals to adjoint A into A is equals to determinant A into I. Hence it is verified. So students, this is very important verification or identity in adjoint. And student, this is the main concept or basic concept of adjoint, which is very important. I hope student you understood that today's three concepts which we discussed in this video. The first concept is minor, second is cofactor, and the last one is adjoints. All three are very important. Student, if you have any doubt in today's concept, you can put your doubt in comment box. And to help the other student, keep sharing our videos. If you are new to our channel, don't forget to subscribe. Thank you, student.